Mr. Estrada here, and there is our learning target. Today I want to talk to you about isosceles trapezoids. So let's begin with a fact. The sum of the interior angles of a trapezoid is 360. And I want you to think about why that is. So if you think about it, a trapezoid has four sides. So here is a trapezoid, and it's got four sides. Therefore, by the polygon interior angle sum theorem, we get the following. So you remember the polygon interior angle sum theorem? We looked at that in the last video. It says the sum of the interior angles is equal to n minus 2 times 180. And if you substitute 4 for n, you would get 360. So we could say that the sum of the interior angles of a trapezoid is 360 degrees. So that is a fact. All right, let's get a little more specific and let's talk about isosceles trapezoids. So as with all trapezoids, isosceles trapezoids have only one set of parallel sides. So in the trapezoid here, line AB is parallel to line DC. And we can also indicate that in the diagram with these arrows on the respective lines. So all trapezoids have one set of parallel sides, and so will isosceles trapezoids. The base angles are also congruent. So what that means is angle D is congruent to angle C. So these are base angles. But also, if you think about it, this is also a base, but angle A is going to be congruent to angle B. So you got the two top base angles and the two bottom base angles. The bottom base angles are equal to each other. The top base angles are also equal to each other. Okay? The legs are congruent, and what that means is that side AD is congruent to side BC. So side AD is congruent to side BC. The legs are congruent. So AD is a leg, BC is a leg, right? It's isosceles, so it's got to have two equal sides. And finally, the diagonals are congruent. So diagonal BD is congruent to diagonal AC. So diagonal BD is congruent to diagonal AC. So those are some properties of isosceles trapezoids, and these are the properties that we're going to be applying in our examples going forward. But before I go on any further, I want to also point out one other thing, right? If we have two parallel lines, as we have here, line AB parallel to DC. And let me just erase some of this stuff to make my point. Let me highlight the parallel lines. So we have line AB parallel to line DC. And then so these are parallel to each other, as we said earlier. AB is parallel to DC. And then we have this diagonal. Well, we got two diagonals, but I'm going to highlight diagonal BD. I want you to also realize that this angle here is an alternate interior angle with this angle here. So angle ABD is equal to angle CDB. And even though that's not said here, it's implied. So I'm going to write that down. So implied alternate interior angles. And that's something you got to keep in mind, all right, because that may come up for some of our problems. All right, so here's example 1. The trapezoid below is isosceles. Find the missing angles. So if it's an isosceles trapezoid, we know that this angle has to be equal to this angle. So automatically angle A is equal to 60 degrees. So this is 60 degrees. All right, now we got to find these two angles, angles D and C. Well, what do we know? We know that these two angles are also going to be equal to each other. So I could label them both X. So I know that 2X plus 60 and 60, which is 120, equal 360, right? Because they all have to add up to 360. So what you're going to do now is you're going to solve for X, minus 120, minus 120. 360 take away 120 is equal to 240. Bring down the 2x. So you get 2x equals 240. Divide both sides by 2. X is equal to 120. So that means that this angle here is 120 and this angle here is 120. And the reason why I set it equal to 360 is, if you recall, like our first fact was that the sum of the interior angles of a trapezoid is 360. So that's why I could set it equal to 360. So our final answer is angle A is 60 degrees, angle D is 120 degrees, and angle C is 120 degrees. Let's try another example. In the diagram below, AB is parallel to DC. AD is congruent to BC, so that's telling us that we have an isosceles trapezoid because two of the sides are equal. Measure of angle A is 4x plus 20. Measure of angle C is 3x minus 15. Well, since we know it's an isosceles trapezoid, we know this angle has to be equal to this angle. So this here is also 3x minus 15. And we also know that this angle is equal to this angle. So this angle here is also 4x plus 20. And what we know is that all the angles, angle A plus angle B plus angle C plus angle D, have to add up to 360. So we substitute. So we got 4x plus 20 plus 4x plus 20 plus 3x minus 15 plus 3x minus 15. And we're going to set that equal to 360. Whoops, I wrote 30. Equals 360. So when you combine all the like terms, you get 4x plus 4x, that's 8x, plus 3x, that's 11x, plus 3x. So you get 14x, 20 plus 20 is 40, 40 minus 15, you're going to get plus 10 equals 360. And what you should get for x is x equals 25. If x equals 25, they want angle D. So angle D is equal to 3x minus 15. Substitute for x, you got 3 times 25. 3 times 25 is 75. 75, take away 15 is 60. So the answer is 60. Angle D is equal to 60 degrees. Let's try another example. Example 3. In the diagram below, isosceles trapezoid DEFG, DE is parallel to GF. DE equals 4x minus 2, EF equals 3x plus 2, FG equals 5x minus 3, and GD equals 2x plus 5. Find the value of x. Now, here, this is focusing on the sides. This is not an angle question. These are all sides. Do not set them equal to 360. That is incorrect. Do not set them equal to 360 because it's talking about the sides. What do we know about the sides? We know that this side is equal to this side. So that means side DG is equal to side EF. Therefore, I could say 2x plus 5 equals 3x plus 2. And I can solve for x that way. So I get minus 2x, this cancels out, and then I can move the 2 to the other side, minus 2, this cancels out, and I get x equals 3. So the answer is x equals 3. Alright, I hope this video helps you with isosceles trapezoids. Have a good day. Take care.